Hello everyone, welcome to the YouTube channel Mission Net Physics Exam. And guys, today in this video I'm quickly going to discuss many important concepts, formulae and tricks of thermodynamics and statistical physics. So this is going to be a quick session, a quick video in which we will talk about these important formulae, concepts and many important things from thermodynamics and statistical physics part. I hope this session is going to be helpful for every one of you guys, those who are preparing for the upcoming CSIR NET exam or even for GATE exam or GIST or TFR or any of the other exams. Similar exams preparation if you are doing, then this session, this video will be helping you a lot to know about many important concepts quickly, easily and in such a way that you will not have any doubt anywhere in the discussion, okay? Or even when you will be applying these concepts in the questions, you will feel more confident about the preparation of the subject. So it's a great opportunity for everyone to learn many concepts in very less time. Even if your friends are preparing for the upcoming CSIR NET exam, GATE exam, GIST or again TFR or any other similar exam, you can share this video with them and you can help them in their preparation as well. So don't forget to share the video. One more thing, if you are new on this channel, that is Mission Net Physics Exam, then you can subscribe this channel by clicking on the subscribe button below this video. Also guys, click on the bell icon so that you will keep on getting the notification for the new videos which I will upload on this channel, because now all the videos which will be there in upcoming days will be helping you a lot to take your preparation to the next level. And with all these videos in very less time, you will be learning many important concepts which are going to have the great chances to be there in the questions in your upcoming exam. So based on these concepts, you can expect the questions in the upcoming exams. So let's start the discussion now. Also guys, you can call it the quick crash course session on thermodynamics and statistical physics, as when you will be attending it, watching it, you will get to know why I'm going to call it this way. Done. Also guys, before I'm going to proceed further, I would like to tell you one more thing, that if you want to attend the well-structured and well-planned courses sessions by the top educators on Unacademy, then you can take the Unacademy Plus or Unacademy Iconic subscription. What are the benefits you will be getting if you will take the Plus or the Iconic subscription? That has clearly been shown here on the screen. And whenever you will proceed further to take the subscription, you can use and apply the referral code, which is Anjali A Live, as mentioned here on the screen. So you can directly write the referral code as, I'm going to write it here. Okay, simply with like in capital letters, everything you can write. That's going to be ANJALIALIVE, Anjali A Live. That's how you can write it. Okay, just as you will be applying the referral code, you will be getting the 10% discount in the total Unacademy subscription amount. Even in upcoming days, many new courses by the top educators will be starting on Unacademy. So if you don't want to miss them, you can take the subscription and start your preparation under the guidance of top educators. Few more important slides like this one. Free unit wise PYQ tests are available on the learning app now for different streams. It has been shown here. The UA Lite subscription is available too, okay, where you will be getting few, like some of the benefits as they have been mentioned here on the screen. Get access to, okay, test series, question bank and the previous year question papers. The information we had from the official organization, okay. Also our exam will be in September now, and I think if you will be checking out the official site, you will find that the application process has now been started. So you all can check that, or you can start filling the application form. Okay, now let's start the discussion about the tricks, concepts and the most important points which we will cover up here. And that's going to be a quick discussion. So you have to focus on the discussion much more. You have to be attentive when I'm going to discuss some concepts. And if somewhere you are going to find like something is not gonna get clear at that point, you can either comment about that or you can check out that part once again. I hope you will be getting it. First of all, whenever you are going to cover up the important topics of thermodynamics and statistical physics, the relation between the thermodynamic parameters is very much important, and sometimes students are going to make mistake in the relations, the expressions they write, the formulae they write. So just to avoid this thing, that you will not be making any mistake, you will not be considering or doing any kind of mistake in those expressions and the formulae, I'm going to tell you a trick. Now what is the trick? Let's consider it. It's going to be this way. Look at this. So you have to make a structure like this, Okay, you have to draw it this way. This will help you to avoid making any kind of mistakes in the thermodynamic relation and the parameters. So you need to prepare a statement. I will be repeating it twice. Okay, so if you will miss it once, you can note it down second time. Great physicists have studied under very fine teachers. What I have said, once again I'm going to repeat it. Great physicists have studied under very fine teachers. So G for great, physicist P, have H, studied S, under U, very V, fine F, teachers T. I hope you all are gonna get it. G for Gibbs free energy, P for pressure, H for enthalpy, S for entropy, U for internal energy, V for volume, F for Helmholtz free energy. Sometimes in some of the questions or books you can find it denoted with A, the Helmholtz free energy or free energy, just we can call it. T for temperature. Okay, now in this structure you have to consider the slides. For example, this one, higher to lower point, it's a slide available in this structure, which means if somebody will sit here at the topmost corner, will slide down and reach easily to the other opposite corner. Same way, this is the slide available. Okay, so if somebody wants to go from lower to higher point, there is no such option, there is no such slide which will be taking them from the lower to the higher point. So if somebody wants to move from the lower to higher point, they will consider that it's a negative aspect, that they can't easily move this way. So higher to lower, always we will take positive because it's a slide available, it's easy to move, but lower to higher we will take it negative. Okay, I hope it's clear. Now let's proceed further. So we will be writing first of all the expressions for dH, the center part. Okay, this one, du, that's this one, dF, okay, change in energies, dg. I hope it's clear. Now their neighbors, for whatever you are going to write the expression, first of all you will write in the same way, like dp ds. Why? Company does affect. If you are having friends and you stay with them, you spend much more time with them, so you adopt their habits, you become somewhere or in some way like them, you are going to have some of the similar habits like them. Okay, so that's how similar expressions you will write. Now move to the opposite corner. Okay, diagonally opposite corner. So P to V, so it's going to be higher to lower point, positive sign. S to T, so higher to point, lower point, positive sign. Okay, now next thing, du neighbors, first of all ds and dv, opposite corner, S to T, positive sign, so TDS. V to P, opposite, not higher to lower, it's lower to higher, so minus PdV. Clear? Next thing, it's gonna be dt dv for F. You can see in the same way I'm going to write, lower to higher point, negative sign. Okay, lower to higher point, negative sign. Now next thing, dp dt. Once again, higher to lower point for dp, it's gonna be V positive, and lower to higher, see, higher to lower for dp, because p is here, higher point to lower, so positive I have taken. Lower to higher, okay, this was higher to lower, now lower to higher, it will be what? It will be negative, so minus t s dt. Okay, now you can see how easily I have mentioned all these expressions in the formula here, so you can easily do that. It's a kind of trick, you can say, and you can even check out, as I have told you, high to low diagonally positive, okay, low to high diagonally negative. So anytime if you are even going to check out these signs, let's even check them once. dh dp ds, positive positive, correct. du ds dv, positive negative, correct. df dt dv, negative negative, correct. Okay, dg dp dt dt, negative, and dp positive, correct. Done, everybody has got it. Okay, now next thing, one more thing we will be doing to write the Maxwell's relations in thermodynamics, but what is that thing? Let's talk about it. Once again, I'll be making this a structure. I'm just going to keep on continuing the discussion. Why? Because in just less time we want to cover up many things. So if anywhere you're going to find like something is not getting clear to you, or somewhere there is any doubt, you can check it once again, or you can comment about that. We will try to consider that discussion. Once again, same structure. Great physicists have studied under very fine teachers. One more thing, you have to prepare, like if you will be preparing this trick or this way, you will never ever make mistake in any sign. And one more thing, these expressions are very much important, because in thermodynamics you can expect the questions related to these expressions, so you can't skip this part if you want to make a good command on thermodynamic and statistical physics part. One more thing guys, here you have to consider first corner, second corner, third corner. Vertices of the triangle we are going to consider. So from first we will start, so delta 1 upon second we will reach there, and third we will take as a constant. So higher to lower point you have reached, from 1 you have started until third, you like towards third you have moved, so it's positive. But at the same time you will equate it, from the last corner you will move in the opposite direction where you have ended the motion for the first right angle triangle. So for this one it will be x, it will be y, it will be z, let's say. So you will take delta x upon delta y at constant z, okay, and lower to higher you have moved, because it's in opposite direction you have to move. First one in clockwise direction, second one in anti-clockwise direction. So lower to higher means negative sign. That's how you have to consider it. Let's consider it this way here. PSV, delta P upon delta S at constant V. We have moved P to V, positive, is equal to TVS, delta T upon delta V at constant S, negative. Reason behind it, because TVS is what? Lower to higher. T is the initial point, S is the final point. So negative sign. Next, from S, from P we have started earlier, now we will start from S. So delta S upon delta V, and at constant T, S to T you have moved, so positive, is equal to delta P upon delta T at constant V. P, T, V, higher to lower, that's gonna be again positive. So this way you will be able to write all the Maxwell's relation. Once you have started from here, second time you have started from here, third time you will be starting from here. So this to this to this, then this to this reverse. Okay, that's how you will be writing it, and depending on higher to lower or lower to higher you are going to move, you will be taking the sign according to that. The sign convention will remain same. I hope you got this trick as well. Now the next thing, that is equipartition theorem. So if any time you will have the Hamiltonian of any system given to you, and for example there is p square term along with some other part, and there is x square term along with some other part, so you will say that the energy associated with the every quadratic term, each quadratic term present in the Hamiltonian will be half kBt. So for p square you can write the energy associated with it half kBt. At the same time for the x square you can write it half kBt. But remember, if any time it will be x to the power 4, if it is not x square but it is x to the power 4, so you can write it as x square, but you will not be making any changes in half kBt part, just half you will change. Okay, bye. If you will be making changes in kBt, let's take the square of it, then dimensions and unit will also get changed. So remember, you are not going to change that. Okay, so the energy associated with the each quadratic term present in the Hamiltonian is what? Half kBt. That's the equipartition theorem statement everybody needs to know. Next is going to be the calorimetry principle. Now what is that? Let me just tell you about it. So if I'm going to talk about the calorimetry principle, guys, it says that if there is going to be a system which is having two compartments in it, and when there are two compartments, what will happen in that case? Let's say there is a wall which is separating both the compartments in such a way that nothing can pass through this wall, okay, from one side to the another side. So that means what? They are separate, they are completely isolated from each other. Let's say the number of particles in this case is m1, or total mass of all the particles can be given to you as m1. Any of these things can be given. So I'm writing in general like both, and then temperature T1, volume V1. Okay, and the specific heat capacity of the substance present there is C1. Same way here you can take number of particles, either that will be given or mass will be given. Temperature, volume, on the second side of the compartment, mass of like overall mass can be given to you. It's not each particle mass, I'm telling you right now. Okay, it's total mass, it's total mass, either number of particles or the mass will be given. Total mass is given, then we don't need the number of particles. So if this is the case, and slowly you are going to remove this wall from the center, in that case they will just mix up. Mix up means now there will be a point when you will find that the equilibrium temperature you will get. So the formula for the equilibrium temperature as per the calorimetry principle is m1c1 t1 plus m2c2 t2 upon m1c1 plus M2C2. If there will be same substance present on both sides, so specific heat capacity will be same. Or if you will have like number of particles you know and each particle's mass you know, so N1M, N2M. If same particle, same substance will be there, same way N1M, N2M. So you can take M common and you will be able to write the complete expression in terms of N1 and N2. Okay, or specific heat capacity will be same, then again you can take them equal, C1 is equal to C2 is equal to C. So this is how you get the equilibrium temperature information from the specific like calorimetry principle. Also, if we are going to talk about the general expression which you may have to use is the ideal gas equation, PV is equal to nRT, which is even very much important and you may have to use it anywhere depending on the question. Now after taking this much portion of thermodynamic and statistical physics part, I would like to tell you about one more concept of thermodynamics and statistical portion, and then purely statistical part discussion I'll be doing. Then that is related to critical point. If anything you have to find something related to critical, like critical temperature, critical pressure, critical volume, critical related. So the conditions corresponding to that is, first one, delta P upon delta V is equal to 0. Second one, delta to P upon delta V square is equal to 0. If number density related expression is given, at place of V you can also take the rho, that is the number density. It will also be giving you the right answer. So anyway you can solve such type of questions by writing the rho expression instead of V or V expression. To find the answer for any critical condition you will be using these conditions there, okay, and you will be getting the answer. Next is statistical physics portion, guys. If any time you are going to work on the statistical physics part, then you can consider the partition function. Okay, it's very important factor of statistical physics. It's very important formula and it is present at so many different places in statistical, so it's very important. Summation over I, Gi is the degeneracy, e to the power minus beta Ei, and then E is energy, beta is what? Beta is the inverse temperature, you can call it 1 upon kBT. What is G? G is the degeneracy here. At the same time, if we will talk about the average energy, that's going to be summation over I, Gi, Ei, e to the power minus beta Ei upon summation over I, Gi, e to the power minus beta Ei. Then average energy, you can see what is the difference. In this expression only energy I have noted down, and the below part, the denominator part, is exactly same. At the same time, if I will talk about the next thing here, that's going to be the probability, because from this section we mostly get the questions. So probability is what? That's going to be the favorable part, that is G e to the power minus beta E, and it's not necessary that only one term will be the favorable one. Even more than that, you can have the favorable terms. All that you can write in the numerator just by adding them together depending on the question which will be given to you, and the partition function in the denominator, which is this one. So this is how you will be able to consider it. It's the probability expression you will have. Now one more thing I would like to tell you here, that is depending on the statistics. For example, you have to prepare all the formulae and the conditions I am telling you here, because these all are very much important, and after covering this much portion you will find like most of the portion which is very important and from where there are great chances of getting questions in the exam, you will get cover it up with this session only. As well as I'll try to take the more questions from the previous years in this these upcoming sessions, these upcoming videos. So be regular in the sessions, don't miss them, don't miss the videos I will be uploading here on the channel Mission at Physics Exam. You will get to know about many important concepts this way. You will get to know how these concepts work in the numerical or the previous year questions, what type of questions have been asked there, okay, or what you can expect in upcoming exam as well. There are three different statistics we mainly talk about: Maxwell-Boltzmann, okay, Bose-Einstein, and Fermi-Dirac statistics. If I will talk about the Maxwell-Boltzmann statistics, there we are going to have the distinguishable particles. At the same time, the Bose-Einstein statistics, indistinguishable particles. And then for the Fermi-Dirac, it's about the indistinguishable particles. If we will talk about the next thing here, distinguishable particles, these are the classical particles which follow this statistics. Any number of particles you can fill in a particular state. Here also any number of particles, but these Fermi-Dirac statistics like fermions follow it, and you can fill the particles as per the Pauli's exclusion principle. Means if particles are having the same spin, you can't fill more than one particle, or two particles cannot be there with the same spin, okay. Two particles cannot be there if they are having the same spin. So if you are filling the particles having the same spin, only one particle in one state can be there. Okay, so that's how, like mainly for the Fermi-Dirac, you have to be careful about the number of particles you will be filling in one particular state, as it follows the Pauli's exclusion principle. I hope you all are getting all these points I have covered here, guys, and thank you so much everyone for watching this video till the end. Let's keep it this much in this video, and tell me in the comment section whether you are finding this video helpful for you or not. If you want to join the more regular live classes of well-structured and well-planned courses by the top educators on Unacademy, as many new courses in upcoming days will be starting on Unacademy, then you can take the Unacademy Plus or Unacademy Iconic subscription, and whenever you will proceed further to take the subscription, you can use and apply the referral code, which is Anjali A Live, as mentioned here on the screen, and by using and by applying this referral code, you will be getting the 10% discount in the total Unacademy subscription amount at the same time. Also guys, many other courses by all the top educators which we are having on Unacademy will be there, so you can join any of the courses after taking the subscription, and you will be able to take your preparation to the next level under the guidance of top educators in the remaining days before the exam. It will be helping you a lot to do the best preparation. Thank you so much everyone for watching this video till the end. Thank you.